to this video where we will perform a sensitivity analysis on our model to see which parameter most affects the ending value in the account in cell G26. Recall our example used in the first video, which is a simple amortization table modeling a college savings account. Remember, we used a static deposit of $10,300 for years 1 through 17 before we start withdrawing the funds starting in year 18 when the oldest child goes to college. Cell G26 shows the ending balance of the account after tuition has been paid for all 4 years for both children. One feature of Analytics Solver Platform is its ability to automatically find the input cells with the greatest impact on any selected formula cell. You can use this information to determine where uncertainty in a parameter might have a particularly large impact on the insights suggested by the model. To do this, we simply select this cell, in this case cell G26, then select Parameters, Identify. Analytics Solver Platform has traced through all precedent formulas to find the input cells on which cell G26 depends. It has varied each input cell independently, computing its impact on cell G26. The input cells have been ranked in descending order by absolute impact, and the highest impact cells are displayed in this tornado chart. This chart shows us, at a glance, that the cell in which we are interested, cell G26, is most sensitive to changes in the value of cell D3. Now if I pull this down a little, that cell D3 controls the amount of deposit for years 1 through 17. It is next most sensitive to the value of cell D23. Now if we look at cell D23, we find that that is the largest withdrawal we're going to make. And recall that that withdrawal is large because the oldest child will be finishing his senior year in college and the youngest child will be attending his first year. So we will have to make a double payment of $75,000, one for each child. This information gives us guidance in terms of where to focus our attention. Specifically, if we are uncertain about the parameter values in cells D3 or D23, we could explicitly incorporate that uncertainty into our model, since the values in those cells have a relatively large impact on the final value of cell G26. The right panel of the chart shows the lower value and upper value that were used for each input cell when computing the formula value. Typically, a cell containing a number is set to its current value plus or minus n%, where n%, which by default is 10%, is specified in the edit box in the lower right-hand corner of the chart.
Let's take a look at a different model. Imagine that a company wants to determine whether to go ahead with the development of a new product that will be introduced to the market this year and will stay on the market for 5 years. Without knowing any other information, we can determine what parameters most affect the total NPV by clicking on cell C54 and then selecting Parameters, Identify. Cell C26 has the most impact on the value of cell C54. If we take a look at the spreadsheet, we see that cell C26 is the selling price of a Class A customer. The value of cell C54 increases when this parameter value increases, as shown by the blue bar. The next most sensitive parameter is cell C25. Notice the switching of the red and blue bars. This means that when the value of cell C25 decreases, then the value in cell C54 increases. Tornado charts are a powerful tool that we will use in several places in this course. See the next video to learn how to add uncertainty to your model.